Let's continue studying for the 2023 Northern Hemisphere Chemistry exam. This time, it's the fifth question in the short answer section. It's an experimental question. The purpose of VCE science education is to develop students' scientific thinking. It teaches students to explore the world using scientific methods, validating scientific theories, discovering and explaining new phenomena, and understanding the impact of science on daily life, society, and the environment. The goal is to cultivate students' critical scientific thinking, teaching them to evaluate the reliability of scientific hypotheses, research methods, results, and conclusions. It also requires students to understand the ethical challenges faced by science. Assessing students' scientific An experimental question consists of 4 parts: purpose, method, data, and conclusion. The experiment is designed based on the experimental purpose, followed by the actual experimentation. After completing the experiment, data is obtained. Based on the experimental data, conclusions are drawn, and the final step involves assessing whether the conclusions support the hypothesis. The core of the experimental question is variables. The hypothesis identifies the independent and dependent variables. The method and procedure also involve controlling variables. The process of the experiment is to observe and measure the numerical values of these variables. VCE exams often assess 3 aspects: error analysis, summarizing and synthesizing data, and inferring or judging the reliability of conclusions. Error analysis begins with variables, assessing potential errors that may result from obtaining variables, including systematic and random errors. Sometimes, candidates must graph experimental data, while other times the question provides the graph directly. Describing and explaining the graph is a challenging and crucial aspect of the exam. Describe the relationship between the independent and dependent variables and explain how scientific principles elucidate the independent variable's influence on the dependent variable's variation. Based on experimental errors and graphs, candidates can then judge the reliability of the experimental data and conclude. Now, let's take the example of the 5th short answer question in the 2023 Northern Hemisphere exam to see how these principles are specifically applied. This is an experimental question, comprising 4 key elements: purpose, method, data, and conclusion. The experimental purpose was to investigate the relationship between the oxidation rate of luminol and temperature. From the research objective, it can be deduced that temperature is the independent variable, and reaction rate is the dependent variable. Since the rate is a function of time, time became another independent variable. The experimental setup should include a timer. The materials for the experiment were luminol and nickel. As luminol oxidizes, it produces light, so the observed indicator is light density. Light density is measured using a photometer. In this case, light density is the dependent variable. Temperature is controlled using a constant temperature water bath, effectively controlling the independent variable. A thermometer is used to measure the temperature. However, there is a lack of a stirring device. Insufficient stirring may potentially affect the independent variable, time. Controlled variables include the concentrations of reactants, which remain constant. The constant temperature water bath has a lower container containing luminol, and the upper pipette contains nickel. Before mixing, both luminol and nickel need to be preheated to the set temperature. However, exposing nickel outside the constant temperature water bath may result in heat loss, leading to a temperature change and introducing an error to the independent variable, temperature. Additionally, as the pipette is not equipped with a stirring device and the addition times of luminol and NaOH are different, there may be errors in the independent variable, time. Controlled variables, such as reactant concentrations, do not have errors because the pipette had been rinsed with NaOH. In the actual exam, candidates can quickly read through the methods section, focusing on key points such as both reach 10 and rinse a 40.00 milliliters pipette. When answering questions, they can refer back to this section for guidance. This PPT presents the results. The curve of light density against time can be divided into 4 parts: ascent, peak, descent, and 0 point. There are 4 questions: the effect of temperature on reaction rate, describing and explaining the curve, drawing conclusions, and identifying sources of error. When encountering a question with multiple parts, students should read through all the questions before starting to answer. Understanding the question is crucial. 2 key words: rate and different temperatures. Review the experimental purpose, the effect of temperature on the oxidation rate. Lastly, check the score, 2 points. This means answering 2 key points. Look at the score before answering, and start writing only after considering the points. Returning to the results. The graph tells us that the curves at different temperatures have 3 distinctions: the peak value, the slope of the descent, and the time to return to 0. Simply mentioning these 2 points can earn 2 points. Note: the time taken to reach the peak is not the correct answer. This time interval was an error, and it's a systematic error. Describe and explain the change in light density over time at a temperature of 30 degrees. 4 marks are rewarded. 2 points are given for describing 2 characteristics. Another 2 points are given for explaining these 2 characteristics. Ascent, 3 seconds to reach the highest value because it takes 3 seconds for the reactants to be thoroughly mixed. Decrease, the drop to 0 point for about 2 seconds is due to a decrease in the reaction rate due to a decrease in the concentration of the reactants. The reason it dropped to 0 is because the reactants have. Understanding the question is key. The question requires writing a conclusion, and since it is only worth 1 point, simply stating the conclusion was sufficient. Recalling the experimental purpose and referring to 5a, it is not difficult to conclude that the higher the temperature, the faster the reaction. Error analysis in the experiment remains consistent each year, with 2 error sources given, totaling 2 points. Each error source is worth 1 point. The question provides 2 assumptions: the experimental method's design, steps, and logic are flawless, and the instruments are precise. How to approach it? Start with the variables. Simultaneously, consider the experimental method. The controlled variable was reactant concentration, which must remain consistent. The methodological aspect included pipette rinsing, ensuring no error in the controlled variable, i.e., reactant concentration. The independent variables were temperature and reaction time, and the dependent variable is light density. Error analysis begins with how to measure and control the independent and dependent variables. Insufficient mixing due to the lack of a stirrer introduces an error in reaction time because thorough mixing took time. When adding NaOH with a pipette, the time it took for complete entry may vary, introducing an error in reaction time. Although the reactants were preheated to the required temperature, exposing NaOH to room temperature when adding it with a pipette may still cause temperature variation in the NaOH solution, leading to an error in reaction temperature. There was only one photometer, which may not entirely record all light. Assuming uniform light in the reaction system with a single photometer may be a simplification. The system's thermometer and pipette may obstruct light, causing uneven light and introducing an error in the dependent variable, light density. Students can score by addressing any two of these points, ideally providing brief explanations. If you need my help, please add me on WeChat and WhatsApp by scanning the QR code. You can also reach me directly via email. Follow Dr. Lu's VCE Physics, Chemistry, and Biology channel on YouTube. Finally, I wish all students success.